Hello everyone, so today I want to teach you what is callback property. So what will be in this clip, we will see the docs of callback property, pros and cons, synchronously drawing, but destroy performance, position callback property, my code example for callback property without animation, send castle callback property with animation. So from the docs, it's just a property whose values is lazily evaluated by a callback function. Okay, so it got a callback and constant is constant, which if it false, the value if the value will change. Okay, in other words, if it dynamically or not dynamically. So there are pros and cons. So the pros, it makes the entity to be drawn synchronously, which means entities will be drawn without flickering or blinking. It's very good, it's awesome, but it's good for dynamic entities. That's the only way to entities to be drawn synchronously. And now it's version 1.76 and there are no other option to draw entities synchronously. Okay, so this is the pros, but the cons, it executes the callback every single frame, so it can ruin your performance drastically. So for me it was a case that I created one polygon and added to him a callback property to the position hierarchy. I created a 360 position, and I feel that it ruins the performance really. Okay, and if you want to use a request render mode, it may make your request render mode useless. Not every time, but sometime. Okay, so be aware for this. Another thing about the cons, I asked a question in the Cesium forum. If does callback property destroy primitives behind the scenes? Okay, so the answer is yes. There are no magic here. How it runs synchronously, so it create and recreate every time a primitives behind the scenes. Okay, another thing, position callback property. If I want to give a callback property for position, for the position and entity's position, I use TypeScript, and here I accidentally see this error message that I can because somewhere is it missing the following properties from the position property. Okay, so I find that there is their issue in GitHub, and they ask for this, and it answer him. It only works with callback property by accident in some parts of the code. Interesting. So until Cesium stuff will fix it, if you need a callback property for the position in TypeScript, you can create a position callback property. So how I told before, there are no real inheritance here. So only one you need to do is to have the functions, I mean the methods and the properties which callback property have and position property have, because otherwise it will tell you missing ABC. No, never mind. Okay, so you need to create a class, for example, position callback property, and the code, I mean how to implement this, you just go to callbackproperty.js and copy the implementation. Okay, you don't need to recreate it. But you saw before the position property has a frame. I don't remember frame. Never mind. You can make it empty there. Also, you have a Cesium.js that you also from there and combine from there the definitions. And I did it once, it worked. Okay, so let's see my example and then the sandcastle example. So my example, okay, it's a little bit stupid. I create a billboard and the scale is used callback property and it looks very ugly, but it's not the point. The point is how to use callback property. Okay, so again, also here, ignore that it's Angular here. I just use it for the TypeScript, and here I create the viewer and I call the function draw. I use here the position and create an entity ID, position, billboard, image, and see, look to this scale. I tell him you are new callback property and you return some random integer between 0 to 5, and this is what you saw before. But the point here, I give to the callback property a callback property without animation. And now we will see an example from the sandcastle where we use the animation. Okay, so go to the sandcastle, then there to the beginner, and then to the callback property example. Okay, so this is how it looks like. It creates a polyline. Looks good. Okay, it's dynamically very beautiful. So let's see the code. I create the viewer. I tell to the clock you should animate. Okay, so never mind. I don't really understand the animation, but it's not the point. We create the start latitude, start longitude, and the start time. We tell take the current time. Okay, you don't use a time from JavaScript, but the time from Julia and Cesium. Okay, and now consider to this is constant false. It means it will be dynamically. The positions are dynamic, and here we create the polyline entity, and you see positions. Positions return. We need to return an array. So here we return the first start longitude, start latitude, and the second position and longitude and start latitude. Okay, the latitude stays the same, just the longitude is changed. And here see the end longitude is changing every different seconds in the time. Okay, very simple. Now it's how to draw the polyline, but how to draw the label. So let's go to the label. The label also is very simple. We create a position, but I said before in the presentation that you can't bring to a position a callback property. So I didn't like this, that in the official examples in Cesium you can't copy paste it. Okay, it won't work in TypeScript. Never mind. So here we bring him the position every time the midpoint of the polyline. Okay, you see the start, the end, and it drawn at the middle. And the label also, the text is dynamically every time it changed. So also we need a callback property for the text. After this, I also told you, okay, that you can track the entity. Which entity we have to here? Two entities. So we track the label entity, and this is why we see a movement. Okay, because every time the middle of the polyline is changing. Let's see what is get midpoint. How to calculate the midpoint. So to get that, we get the endpoint by access to the red line polyline positions get value, and here you see we use the animate the time. This is how we access to the endpoint, and after this we convert it to cartographic, and here we use geodesic set endpoints, and cartographic we just right now we calculated. To get the midpoint, you of course could use before, okay, as a surface, geodesic surface distance, and multiply it by half, but you also can use the function interpolate using fraction. Fraction just means you give him a float number between 0 to 1, and it will return you the midpoint, and that's all. Okay, this is how he return us the Cartesian tree of this point, and for this was the position of the label. and the second, the length of the text. Where is it? Get length. Here we also endpoint convert it to cartographic, tell the geodesic to set endpoints, and geodesic surface distance, I told in another video, it returns the distance between two cartographic positions. And after this we divide it by 1000 to be fixed one and add the kilometer string, and that's all.